Now let's start and try to understand advanced data warehousing. What does that mean? So in this tutorial, we will discuss basic data warehousing concepts, dimensions and measures, typical OLAP operations in data warehouses, data warehousing's design and usage, data warehouse implementation. In previous video, we have discussed what is OLAP and OLTP, online analytical processing, online transaction processing. Build a new information repository that integrates the data coming from different sources and makes it available for analysis and evaluation to support planning and decision making. We have also discussed what is data warehousing, which is a collection of method, techniques, and tools that support knowledge worker in decision making by transforming data into information. We have also discussed the data warehouse, like what do we mean by time variant, non-volatile, integrated, subject oriented in our previous videos. So let's do a remind for that. Subject oriented is data is organized around subjects. For example, customer, sales rather than operations. Time variant is all data is timestamped. Non-volatile, previous data is not erased when new data is added. Integrated, data integrated from heterogeneous sources. We have also discussed the difference between the data warehouse and operational database, which means data warehouse is historical, used by executive managers and analysts, used to analyze the business, focus on information. Historical data we do in data warehouse. We summarize and consolidate data. We do customer queries. Queries process large amount of data. Partially denormalized schema. So for example, an electronic store. Suppose we own a business that sells electronic equipment like laptop, phones, printers, headphones. We are doing very well. And we have stores opened in many cities around the country. Eventually, we expand into Canada too. Now, all stores our operations are databases. One database for each store. Keep the information about the transaction in that store. Items available in the store. Used to manage day-to-day operations of the store. Only current and recent data kept. We are most likely not going to keep a transaction of a customer buying headphones 15 years ago. And data can be modified. Now, what does that all means? So for example, operational database is holding product name, product type, quantity, unit price. It's also holding transaction ID, date, price. It's also holding timestamp that when it was done. Now data can be modified. For example, laptop, which was now 3 quantity and 1500 is the price. One warehouse for the whole company. Combine information from each individual store. Keep historical and summarized data. No data is changed, data is only added. Used to analyze and improve the business rather than its day-to-day operations. So data warehouse is more important for the business than the data operations. So for example, now we have all the details from all the stores at one place. Data only added, existing data not modified. So for example, we changed the data. We have added XPS 15. So we just added the data instead of overriding the data. This is the good thing in data warehouse. Now let's try to understand this by cube. Data cube is 3 dimension. So we have product on one side, store on the other side, date on that side, sales all together. So we just adding a data to this. Sometime we refer to cuboid, and cube will individually of individual cuboid. Now let's try to understand this by hierarchies. A concept hierarchy defines a sequence of mapping for low level to higher level. More general concept for dimension. For example, location dimension in Washington, which is in US. So all together, then we have country, then we have state, then we have city. So this is how we do this. Now, if we try to understand this by measures, a multi-dimensional point in the data cube space can be defined by a set of dimension value pairs. Time equals to Q1, location equals to Seattle, item equals to laptop. A data cube measure is numeric function that can be evaluated at each point in the data cube space. For example, for any time, location and item, we can calculate total sales. For time Q1, location Seattle, item laptop, total sales is the sum of money paid for laptop in Seattle in Q1. Typical OLAP operations. We do roll up, drill down, slice and dice, and we do pivot rotate table. Now what is roll up? Aggregation in a data cube either by climbing up a concept hierarchy for dimension or dimension reduction. Example of climbing up a concept hierarchy. Aggregation of total sales by climbing up from city to state. Dimension reduce. Elimination of one dimension from the cube. Eliminating time dimension from the cube that contains time and location. Therefore, aggregating total sales just by location. What do we mean by drill down? Navigate from less detailed data to more detailed data. Stepping down a concept hierarchy from the dimension or introducing additional dimension. Stepping down a concept hierarchy, descending the time dimension to month level rather than the quarter level. Introducing additional dimension. Introducing the item dimension to the cube containing time and location. The third one is slice and dice. Slice is a selection of one dimension, fixing a value for one dimension of the cube, resulting in a slice of a cube. For example, selecting the quarter value to be Q1. Dice is selecting of two or more dimension of the cube. For example, selecting the quarter value to be Q1 and location to be Toronto. Pivot. A visualization operation that rotates the data axis view to provide an alternate presentation. Now let's do the typical OLAP operations. So this is the data cube. In this we have 1, 2, 3, 4, 5, 6. 6 data cube we have. So roll up is this one. Dice down is this one. And this one is drill down. This one is slice. And from slice we have pivot. So this is the very best example for OLAP operations. Now what are the benefits of having data warehouse? What can business analyst gain from having a data warehouse? A business analyst can gain present relevant information, enhance productivity, improve customer relationship management. For present relevant information from which to measure performance and make critical adjustments. Enhance productivity by quickly and efficiently gathering information that accurately describes the organization. Improve customer relationship management by providing a consistent view of customers and item across all lines of business, departments, and markets. Now, how to design a data warehouse? For that, we do top-down approach, we do bottom-up approach, we do combined approach. When we talk about top-down approach, that start with the overall design and planning and proceed with implementation. Bottom-up approach is the start with experiments and prototype based on the available data. Combined approach is top-down and bottom-up in parallel. Step involved planning requirement study, problem analysis, data warehouse design, data integration and testing, data warehouse deployment. For that, we have waterfall method and we got agile method. Waterfall method is perform each step in full before proceeding to the next one. Agile method is rapid generation of increasingly functional system with short intervals between successful relief. So from this what we have learned, to design a data warehouse, we have top-down approach, bottom-up approach, combined approach. And we have two methods, waterfall method, agile method. Data warehouse design process. For that, you choose a business process to model. For example, orders, invoices, shipment, inventory, accounts, admin. Choose a business process grain. The level of detail represent individual transaction, individual daily snapshot, etc. Choose the dimensions to apply. Items, customers, supply, warehouse, transaction type. Choose the measures to compute. Total sales, unit sales, for example. What can you do with the data warehouse? You can do information processing, you can do analytical processing, and you can do data mining. Information processing is querying basic analysis, reporting, and visualization using tables, charts, and graph. Analytical processing using OLAP operations such as slice and dice, drill down, roll up, and pivoting. Data mining, knowledge discovery by finding hidden pattern and association, constructing analytical models, performing classification and predicting, and presenting the mining result using visualization. Now, how to do the data warehouse implementation? So for that, we ask how to compute data cubes, efficient processing of OLAP queries,